Hello, and welcome to Backer Breaks It Down. In this episode, we are going to write some piecewise defined functions given a contextual situation. So that's right, word problems involving piecewise functions. So let's take a look at our example. Okay. So we have a cellular phone company that offers the following plan. $20 per month by 60 minutes. Additional time cost 40 cents per minute. And customers are limited to 2,000 total minutes each month. Okay. So we are going to write a piecewise defined function because this is totally a piecewise situation. We're also going to find practical domain and practical range. Okay. So to help us find a piecewise function, sometimes you need to think specifics because this is going to kind of like help you write a general function formula. Okay. And so part A is totally helping us do that. It says evaluate C of 20 and C of 100. So C is representing the total monthly cost. Okay. Which means that 20 is the number of calling minutes. So how much does it cost for 20 calling minutes? Well, looking at the information they gave us, they said that $20 a month buys 60 minutes. So that means that the 20 minutes would cost $20 because $20 per month buys basically the first 60 minutes. So we can say definitely that the cost of 20 minutes is $20. So what about the cost of 100 minutes? Okay. Well, we just said that the first 60 minutes is $20. So the cost of 100 minutes is definitely going to cost us $20 and then some more. Because that $20 is simply the first 60 minutes. Now, if we are using our phones for 100 minutes, that's like an additional 40 minutes. And they told us that additional time costs 40 cents per minute. So 40 minutes at 40 cents per minute. If we multiply that and add it to our 20 minutes, we'll get the total cost. All right. So that comes to be like $36 for 100 minutes. Okay. So now let's write our function. It says represent this plan with a piecewise defined function in which the total monthly cost is a function of the number of calling minutes. All right. So I'm going to say the cost is a function of the number of minutes. And I'm going to have my set notation bracket. Okay. And so the very first item says $20 per month by 60 minutes. So the total cost is $20 per month. And this is just the first 60 minutes. So we're going to say anything from 0 to 60 minutes, I'm paying the $20 for. Okay. So now let's talk about the additional time, right? And we can use what we wrote, like how we found the cost for 100 minutes to help us do this. Okay. And so exploring what we wrote there, this is what we had. Okay. That's how we calculated the cost for 100 minutes. So we had the 20. The $20 was representing what we paid for the first 60 minutes. And then the next thing we had was 40. So where did we get this 40 from? That 40 came from us going our 100 total talking minutes minus the 60 minutes we already paid for. So 100 was representing our time, and minus 60 is what the $20 paid for. Okay, so basically we have the $20 for the first 60 minutes, and then plus 40 additional cents for each additional minute. And so we can represent those additional minutes using this expression here, the t minus 60, because that's how we got the 40. We went 100 minus 60 is 40, okay? So t minus 60 is representing the time beyond those 60 minutes, okay? So now when it comes to like the domain for this piece, this basically started up when we went beyond 60 minutes. So I can like use a parenthesis and say 60 because I'm not saying 60. I'm saying like 60.1 minutes. That's where this would come into play. Now, what would be the high end of this? Well, up above, and we kind of didn't even address this yet, they had mentioned customers are limited to 2,000 total minutes each month. So that is implying that the second piece of our function would be used to go up to 2,000 minutes, and then that's it. Okay. So parts C and D talk about something called practical domain and practical range. Well, as you know, domain is describing the x values of a function. So the x values in this function is t, so the time. So if we think of the time involved here, look at our two smaller domains. We said there was like a low time of 0 hours. I'm sorry, not hours, minutes, 0 minutes, and like a high time of 2,000 minutes. So that would be our practical domain, because we're talking about what is practical to this situation. So now let's talk about the range. Range describes the y values. And in this problem, the y values are representing that total cost. So we need to think, like, what is the cost for 0 minutes? Well, that's just basically an activation, right? You're paying the $20 even if you don't use your phone. You're still paying the $20 for the month. So then we have to think, how much would 2,000 minutes cost? So we're going to have to figure that out by plugging 2,000 into that second piece of our function. So if I go 20 plus the 40 cents times the 2,000 minus 60, and if I use my calculator to figure this out, I end up with $796. So using my cell phone with this plan, I could pay as little as $20 for the month or $796 if I use all 2,000 minutes. So that's how we write piecewise defined functions for a word problem. It does help to think of how you would go about calculating a specific amount, and that's like what we did in part A. Because like when we calculated the cost for 100 minutes, that really helped us to write that second piece of our piecewise function formula. And so that's a little strategy that you can use in your future applications involving piecewise functions. And that's how Backer breaks it down.